From here onwards, we shall have the questions which will only have the integer type of answers. Well, let's proceed with question number 18. A column of mercury 10 centimeter long is contained in the middle of a narrow horizontal 1 meter long tube which is closed and sealed at both ends. Both the halves of the tube contain air at a pressure of x centimeter of mercury. If it is given horizontal acceleration of 18 meter per second square, then displacement of mercury column is found to be 5 centimeter. The value of x divided by 10 is. Here the x is actually the pressure of x centimeter of mercury. So definitely if initial pressure was P0, I'm just writing it down. It must be written down as it is rho of mercury into G into x in centimeter. Fine. Okay. Now let this part is having the initial pressure as P0, this part also having the pressure P0, this part is having the pressure P1 once it is accelerating, and this part is having the pressure P2. So I would say P0 into volume initially will be proportional to its length itself, would be 45, must be equal to P1. This section has actually been shifted here by 5 centimeter. It will come out to be 40. So P1 is equal to 45 divided by 40 into P0. Similarly for this segment, P2 will be how much? It will be 45 P0 divided by 50. So the change in pressure P1 minus P2, P1 minus P2, it will be 45 P0, 1 divided by 40 minus 1 divided by 50. It will come out to be 1 divided by 200. This is the pressure difference we shall have here once the system would be accelerating forward with the acceleration of 18 meter per second square. Okay, so corresponding to this acceleration, the pressure difference would have been written down as how much it is? It is rho into acceleration being 18 and the distance is 10 in centimeter, and it must be as 45 divided by 200 into P0. P0 was the pressure and that was given as x centimeter of mercury column. So I shall write it as rho G to be taken as 10 into x. This is rho and 10 will cancel out. I'm having the value of x in centimeter as 18 into 200 here, divide by 45. So I'm getting this value to be equal to 80 centimeter. So corresponding to the one that is given here, the value of x divided by 10 will be how much? It will be x divided by 10 will come out to be 8. So we are getting 8 as the answer for question number 18. Now we shall proceed to question number 19. Here in question number 19, a second pendulum is slightly displaced from vertical position. A nail P is pivoted in the wall at a depth x centimeter below the suspension point of the string. If the new time period of pendulum is 3/2 seconds, then value of x divided by 15 is. X is actually length in centimeter. I would say the original time period is T0, that is 2 pi root under L by G. Okay, and this T0 was given how much? It is 2 seconds. So simply 2 must be equal to 2 pi. G was taken to be pi square, so it is pi square root of L. This one is cancelling out, and I'm having the original length L to be equal to 1 meter. So in centimeter it will be 100. Now once this is pivoted here and a nail is pinned at this point at a distance x, so the new time period will be, for half oscillation from here to here, I shall have the new time period as pi root under L by G, and the other being from here to here, this time the length is how much? L minus x. It will be pi root under L minus x divided by G. This one is given as 1 plus how much? 1/2 seconds. This part is the half of the oscillation, already 1 second, so this one will cancel with this particular portion. So I'm having pi here, and this being yet again pi square root of L minus x will be how much? It is 1/2. So clearly L minus x will be 1/4 in meter. This one was already how much? 1 meter. So 1 minus 1/4, it is coming out to be 3/4 meter is equal to x. But the depth x was actually given in centimeter. So I would write this portion as 3 divided by 4 into 100 centimeter. So how much is the value of x divided by 15? Divide it by 15. We will be getting, this is 5 here and this is 5. So we are getting 5 as the answer for question number 19. Now let's proceed to question number 20. Here in question number 20, a stationary source S is emitting sound of frequency 220 Hz. An observer O approaching the source with constant speed records frequency of 240 Hz over a distance of 110 meter. If source is active for the time interval of t0 seconds, then the value of t0 is speed of sound, that is given as 330 meter per second. Well, first we'll try to calculate what is the speed of the observer. It will simply be, f would be taken as v. Here let's say u is the speed of observer, divide by v into f0. The f value was given to be 240 here, and this is v is equal to how much? 330. So 330 plus u0 I would say, and divide by 330 here, and f0 was 220. So it is 2, this one being 3, this one is 120. So now 330 plus u0, I'm getting this value to be equal to 360, or u0 is 30 meter per second. Okay, so the time interval t0 for which the source would be active, the observer has traveled a distance of 110 meter. So in t0 time, the total wave that actually would be generated, it must be 220 into t0, and it would receive those of the wave with frequency of 240 Hz in how much time? In this much of time itself. Okay, so we'll be getting this value of t0 from this calculation as 110 here into 240 divide by 30 into this much. This is 2 here. It is coming out to be 4 seconds. So for question number 20, we are getting 4 as the answer here. So that's the end of this question paper. Hope you must have appreciated the solution, and I wish you all the best for your further preparation. Thank you and goodbye.